Hi, I'm Suzan Murray. I'm the Chief Veterinarian at Smithsonian's National Zoo. I'm here today to talk about the leading cause of death in gorillas, which is cardiac disease. The type of cardiac disease that gorillas experience is similar yet distinct from human disease. In humans, the chief form of cardiac disease is usually related to more of the coronary vessels, but in gorillas it's very different. They suffer from something called fibrosing cardiomyopathy. That's a situation in which fibrous material is laid down within the heart, and that fibrous material can disrupt the flow of the electrical activity through the heart and thereby cause heart disease. We have a large group of people, both MDs and veterinarians, who are looking into this nationally and hopefully within the next few months globally as well. Here at the National Zoo, we're looking into it in many different ways. One of the ways is through an analysis of BNP. It's a hormone released by the ventricles of the heart, brain natriuretic peptide. It's an indicator of disease in humans, and one of our first goals was to find out whether that's also an indicator of cardiac disease in gorillas, to see if we can establish normal values, and then if we could use that to both predict heart disease, follow it along, and monitor treatment and therapies as well. What we found out already is that BNP seems to correlate very closely with clinical heart disease in gorillas. One of the other things that we're looking at in terms of our molecular diagnostics are the interaction between respiratory viruses and the decompensation of heart disease. What that means basically is an animal, human or a gorilla, can be doing fairly well with heart disease, can be compensating fine along with medicine, and then a respiratory virus can pass through, and all of a sudden the patient becomes dramatically worse. One of our hopes is that we'd be using the 454 sequencer to help us identify some of these pathogens that can come through the troop, and if we can identify that earlier rather than later, we can initiate treatment earlier, and that can help us save a lot of gorilla lives. The other part that we're doing here at the National Zoo that we're very, very proud of is we're beginning to learn more about EKG tracing in gorillas. We know what their normal EKG tracings look like when they're under anesthesia, because that's really, up until now, the only way we've been able to get those tracings is to anesthetize them and get that information. But sometimes the anesthetic drugs we use can affect that. One of the technologies that we're trying to borrow from human medicine now is the use of an ILR. That's an implantable loop recorder. It's basically something that's the size of a jump drive, something literally just this size that was developed for human medicine. And in humans, it gets implanted right by the sternum, and it continuously records the EKG rhythms from the heart. It can do that 24 hours a day and then send that electronically to a physician's office who can monitor for minute changes in the EKG wave. These minute changes can help herald the onset of cardiac disease. And the earlier we pick it up, the earlier we can treat. One of the big questions is, would this work in a gorilla? It might have been designed for a 200-pound human with very little musculature. Who knows if it would work for a 600-pound gorilla with huge pectoral muscles? Someone needed to find out, and it needed to be in an institution that had a large interest in gorilla cardiac disease, in conservation, and saving gorillas in the wild and captivity, with a really good training program, and then also a lot of scientists who could share their expertise to further this knowledge. Well, that's where the Smithsonian's National Zoo comes in. We have all of that, and we're very proud of that, and this is a great opportunity for us to use our expertise to unlock these really important questions. So with the aid of our keepers and our reproductive physiologists and our veterinarians and our pathologists and our molecular diagnosticians and our geneticists, we all came together with a plan. We anesthetized 2 male gorillas. Basically, any male is going to be at risk for developing heart disease at some point. So we had 2 healthy gorillas so we can figure out what do the normal rhythms look like, get some normal information, and then that way we'd know if heart disease was beginning to take hold. So we anesthetized our males, and we did a mapping procedure to find out where can we put this where it won't bother the gorillas, especially some of the natural behaviors like beating on its chest, but it can still pick up the recording. we found that there is indeed a spot where we can collect all this information, and it was a spot right on the animal's back, right here. The other great thing about this is it would be a spot that theoretically we would be able to download information routinely. But this is where the important relationship between the keepers and the gorilla comes in. Because one of the questions I ask all the time was, where does a 600-pound gorilla sit? And in this case, wherever our keepers ask them to. Our keepers and the gorillas have such a great relationship that after we implanted this device, we asked the keepers, well, how long do you think it would take to train to get the gorilla to present their back and hold still for 45 seconds? Turned out it was just a little bit over a week. It's truly amazing to go and watch the gorilla present, and then the keepers ask for different requests. Open its mouth, show its arm, and in this case, turn around and lean back. The keepers are then able to put a small wand over the edge of the ILR and download the information. And we're already getting a lot of great information on heart rate variability, normal heart rates in awake gorillas. It's the first time anybody has ever done this, and it's really a huge breakthrough. What we're hoping for now is to continue these great strides we've made in investigating gorilla heart disease, learn as much as we can, not only from some of our captive gorillas, but learn from animals in the wild as well. Thank you very much for listening. I'm Suzanne Murray from the National Zoo.